This presentation is on recurrent neural networks by Mayank Jha. The presentation will have a description on what are recurrent neural networks, the types of recurrent neural networks, the mathematical foundation, the mathematical equation of RNN, parameters and gradients, and finally application of the technique, real-life application of RNN. So an RNN is a type of artificial neural networks which uses sequential data or time series data. These deep learning algorithms are commonly used for ordinal or temporal problems such as language translation, natural language processing, speech recognition, and image captioning. They are incorporated into popular applications such as Siri, voice search, and Google Translate. They are distinguished by their memory, as they take information from prior inputs to influence the current input and output. While traditional deep neural networks assume that inputs and outputs are independent of each other, the output of recurrent neural networks depend on the prior elements within the sequence. The model trains itself by calculating errors from its output layer to its input layer. These calculations allow us to adjust and fit the parameters of the model appropriately. The inputs and outputs can vary in length, and different types of RNNs are used for different use cases such as music generation, sentiment classification, and machine translation. Mathematical foundation of RNN is that the output depends on the both current and past inputs. Let I1 be the first input whose dimension is n into 1, where n is the length of vocabulary. S0 be the hidden state of the first RNN cell having D neurons. For each cell, input hidden state should be one previous. For the first cell, initialize S0 with 0 or some random number because no previous state is seen. U be another matrix of dimension D into N where D is the number of neurons in the first RNN cell and N is the input vocabulary size. W is another matrix whose dimension is D into D. B is bias whose dimension is D into 1. For finding the output of the first cell, another matrix V is taken whose dimension is K into D, where C is bias with dimension K into 1. Mathematically, outputs for the first RNN cell are as below. S1 is UI1 plus WS0 plus B. O1 is VS1 plus C. In general, Sn is UIN plus WSN minus 1 plus B and On is VSN plus C. In general, output O depends on Sn plus Sn and Sn depends on Sn minus 1. Sn minus 1 further depends on Sn minus 2. Process goes till S0 is achieved. This clearly demonstrates that output at the nth time step depends on previous inputs. Parameters in RNN are U, V, B, C, W. These are shared among all the RNN cells. The reasons for sharing is to create a common function which could be applied to all the time steps. Parameters are learnable and are responsible for training the model. At each time step, the loss is computing and is backpropagated through the gradient descent algorithm. Finally, we talk about the applications of the technique. These are visual search, face detection, OCR applications, image recognition. Image recognition is one of the major points of computer vision. It is also the most accessible form of RNN to explain. The image recognition framework includes recurrent neural networks that use the known features to make sense of the image and put together a cohesive description. The most prominent industry for image recognition are search engines, e-commerce, social media. Search engines are the basic application of visual search. Google, Bing, and DuckDuckGo are the most prominent examples of recurrent neural networks image recognition. The goal is to images that fit the input query and to find images that look like an input image. To do that, the image is recognized and described. The resulting information is then used to find relevant search matches. In the case of e-commerce, image recognition is used for object detection and visual search. The goal is to improve the product database and make it easier to navigate. In addition to that, visual search contributes to the product recommendation and consequentially to the service personalization. The way Amazon used visual search results in vast streamlining of user journey and better engagement with more possibilities of further purchases. In the case of social media like Facebook or Instagram, the primary use case of image recognition is face recognition. The difference between face recognition and basic image recognition is an additional layer of processing. There is a general recognition of the shape of the file of the face, and then there is the matching of the unique credentials of the individual face based on available samples. The same principle is also used for transformative filters in photo editing applications. These are the references used for making the presentation. Thank you.